Welcome to the video on increasing and decreasing functions. First, we'll talk about the difference between an increasing and a decreasing function. An increasing function is a function that's moving up, so your slope is greater than 0, or your derivative function will be greater than 0. A decreasing function is a function that's moving down, so your slope is less than 0, so f prime of x is less than 0 or negative. Your function is constant, or a constant function, if it's horizontal and your slope is equal to 0, so your derivative is 0. So for this function here, f of x, it's increasing from negative infinity all the way up to 2. At 2, the slope would be 0, and then it's increasing again until infinity. So you could say the slope is increasing, or the function is increasing from negative infinity to 2, and then we'd put parentheses because the 2 is not included, and then we do a u, 2 comma infinity, because it increases again from 2 to infinity. If you were to have a decreasing function, it could be something like this where it's going down. You could also have a function like a quadratic that looks something like this, where it starts out increasing and then has a slope of 0 and then it decreases. Next, we have increasing and decreasing intervals. To find the increasing or decreasing intervals, you'll set the derivative equal to 0 and find all the x values where the derivative equals 0. Then you'll plug in a number between each 0 and see if f prime of x, or the derivative, is positive, negative, or 0. For example, this says find the intervals where f of x is increasing and decreasing if f prime of x equals x squared plus 3x plus 2. So we'll set our derivative equal to 0. So 0 equals x squared plus 3x plus 2, which we can factor to be 0 equals x plus 2x plus 1. So this will be 0 if x plus 2 equals 0, or if x plus 1 equals 0, which is when x equals negative 2 or x equals negative 1. So on our number line, we want to make sure to have those numbers. Negative 2, negative 1, 0, 1, 2, 3, negative 3, negative 4, negative 5. Okay, so we have the points, negative 2 and negative 1. So now we need to plug in a number between each of those zeros and on the outside. So we'll start by plugging in negative 3 into our derivative. So we'll do f prime of negative 3, which equals negative 3 squared plus 3 times negative 3 plus 2. So that equals 9 minus 9 plus 2, which is 2. 2 is greater than 0. It's positive, so your function will be increasing from negative infinity to negative 2. Between negative 2 and negative 1, we could plug in negative 1.5. So we'd have f prime of negative 1.5 equals negative 1.5 squared plus 3 times negative 1.5 plus 2. So this equals 2.25 minus 4.5 plus 2, which equals negative 0.25. So this is negative, so our function is decreasing in this middle section here. Finally, we have our section to the far right, so we can plug in anything greater than negative 1. So we'll do f prime of 0, which equals 0 squared plus 3 times 0 plus 2, which equals 2. So that's positive, so we're increasing in this final section. So we're increasing from negative infinity to negative 2, in addition to negative 1 to infinity, and then our function is decreasing from negative 2 to negative 1. So here we have our first IB practice question, which is no calculator. It says, on what intervals is g of x increasing and decreasing? So we're given our derivative, so we'll set it equal to 0. So 0 equals negative x cubed minus 2x squared plus 3x. So we can factor out an x, so we get 0 equals, and we'll also factor out a negative so that we can not have that negative in there in front of our remaining x squared. So we'll have negative x times x squared plus 2x minus 3. So now we'll factor our trinomial here. So we get 0 equals negative x times x plus 3, x minus 1. Because 3 times negative 1 gives us our negative 3, and then 3 minus 1 gives us 2. So our zeros are going to be when 0 equals negative x, when 0 equals x plus 3, and when 0 equals x minus 1. So x equals 0, x equals negative 3, and x equals 1. So we'll draw a number line. And we'll go from negative 4 all the way up to 1. So we'll look at things from 0, negative 3, and 1. So first we'll look at something less than negative 3. So we'll plug in negative 4. So g prime of negative 4 equals negative 4 cubed minus 2 times negative 4 squared plus 3 times negative 4. So this equals negative 64, so positive 64, minus 2 times 16, so minus 32, plus 3 times negative 4, so minus 12. So this equals 20. Because 20 is positive, it's increasing to the left. Now we'll plug in a number between negative 3 and 0, so we'll plug in negative 1. G prime of negative 1 equals negative 1 cubed minus 2 times negative 1 squared plus 3 times negative 1, which equals 1 minus 2 minus 3. So this equals negative 4, which is negative. So your function will be decreasing from negative 3 to 0. In between 0 and 1, we can plug in 0.5. So g prime of 0.5 equals negative 0.5 cubed minus 2 times 0.5 squared plus 3 times 0.5. 1/2 cubed is going to be 1/8. So we have negative 1/8 minus 2 times 1/2 squared, so 2 times a fourth, which is 1/2, plus 3 times 1/2, which is 3/2. So if we get a common denominator, we'll have negative 1/8 minus 4/8 plus 12/8. So that equals 7/8. And that's positive, so it's increasing from 0 to 1. And finally, we'll plug in 2. So we'll have g prime of 2, which equals negative 2 cubed minus 2 times 2 squared plus 3 times 2. So that's equal to negative 8 minus 8 plus 6, which equals negative 10, which is negative, so the function's decreasing there. So our function is increasing from negative infinity to negative 3, in addition to from 0 to 1. And our function is decreasing from negative 3 to 0 and from 1 to infinity. So that's it for this problem. Now for our second IB practice question, it says on what intervals is g of x increasing and decreasing, and then it gives us a function that's already factored. So we can find our zeros where each of those factors equals 0. So where 0 equals x minus 2, 0 equals x minus 4, 0 equals x plus 5, and 0 equals x plus 1. So x would equal 2, x would equal 4, x would equal negative 5, and x would equal negative 1. So we can draw a number line where we have negative 5, negative 1, 2, and 4. So less than negative 5, we could plug in negative 6. So we have g prime of negative 6 equals negative 6 minus 2, minus 6 minus 4, minus 6 plus 5, and minus 6 plus 1. So we only need to know if the function is positive or negative, so we don't need to find the actual solution. Negative 6 minus 2 is a negative number. Negative 6 minus 4 is a negative number. Negative 6 plus 5 is a negative number. And negative 6 plus 1 is a negative number. So a negative times a negative times a negative times negative will be positive. For g prime, in between negative 5 and negative 1, we'll do negative 2. So that equals negative 2 minus 2, negative 2 minus 4, negative 2 plus 5, and negative 2 plus 1. So that'll be a negative, a positive, and a negative. 3 negatives is a negative, so it'll be decreasing in that section. Then we'll do g prime of 0 for the next one, which is 0 minus 2 times 0 minus 4 times 0 plus 5 times 0 plus 1. So we'll have a negative, negative, positive, positive, which would be a positive. Then we'll do g prime of 3, which is 3 minus 2 times 3 minus 4 times 3 plus 5 times 3 plus 1, which is a positive times a negative times a positive, which will give us a negative. Finally, we'll do g prime of 5 for our last section. So we have 5 minus 2, 5 minus 4, 5 plus 5, and 5 plus 1, which is a positive, 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 and positive. So that last section will be increasing. So our function will be increasing from negative infinity to negative 5, negative 1 to 2, and 4 to infinity. And then it will be decreasing from negative 5 to negative 1, and from 2 to 4. And that's the solution to this problem. So in summary, an increasing function is a function that's moving up, so your slope or derivative would be greater than 0. A decreasing function is a function that's moving down, so your slope would be less than 0. A constant function is where your function is horizontal, so the slope would be equal to 0. And to find the increasing and decreasing intervals, you'll set the derivative equal to 0 and find all x values where the derivative equals 0, and then plug in a number between each 0 to see if your derivative is positive, negative, or 0. That's all for this video. Thank you for watching.